Hello and welcome to another Redis Tech Talk. Today we're going to talk about the scalability features of Redis Enterprise. As we've talked about elsewhere, Redis Enterprise gives you a data layer that's highly available and doesn't lose your data as things go wrong. That's crucial, but your business is growing rapidly and your data layer has to scale. A great application that can't be used by more than a few people at a time is going to hold you back. Let's start by stating the obvious. A modern database has to scale and scale easily to run your business no matter how much it grows. And of course, the cost of scaling has to be reasonable and it can't slow down performance. In Redis Enterprise, this scaling is handled by the proxy. But first, a bit about Redis Enterprise's architecture. A cluster in Redis Enterprise terms is a set of instances running on VMs or containers or bare metal servers that let you create any number of Redis Enterprise databases. A cluster includes shards, a cluster manager, and a zero latency proxy manager. There's also a REST API component, but that doesn't concern us here. Simply put, the shards in Redis Enterprise are the data itself, the distributed cluster manager manages the cluster, and the proxy is the intelligence between the application and the data. It keeps track of where all the data is located. In Redis Enterprise's shared nothing architecture, every database has its own proxy, and because Redis Enterprise is multi-tenant, a Redis Enterprise cluster can manage multiple databases of different types on the same cluster resources, and all of them are completely isolated from each other. So now, back to the proxy. The benefit of a proxy is that it maintains the database endpoint and abstracts the details of the cluster from the application. All an application has to know about is a single endpoint. Even if the data is moved or resharded, the endpoint doesn't change. From the application's point of view, the proxy is just one big Redis instance with a master role. The proxy also enhances security and improves performance. Each node of the cluster has a proxy, and that proxy forwards requests to the correct shard as needed and manages data encryption through SSL. It provides strong client-based SSL authentication, and finally, it improves performance through pipelining and connection management. Just to put this in perspective, with open source Redis or other Redis services offered by cloud vendors, it's the application's responsibility to maintain mapping between the data and the shard, which can be almost impossible to manage in an environment that regularly grows. With Redis Enterprise, you get a server-side proxy that gives you a single endpoint. Your data may move, but your application uses the same endpoint. Although the proxy is extremely efficient and can usually handle more than 1 million ops per second when running on a modest cloud instance or physical node, there are some situations in which scaling the proxy is needed to deal with network bandwidth or packets per second limitations. Redis Enterprise allows you to scale the proxy across multiple nodes of the cluster, again, without changing your application code. We'll talk more about scaling next. But all in all, the proxy enables a single endpoint to your database. Your database can span multiple shards. You can add or remove shards from the database. You can move shards to another node. It doesn't matter. Your application still connects via the same endpoint. This means you don't have to make any changes to your application code as your database size increases. That's a great advantage that you don't get from open source Redis. Now let's talk a little bit about scaling. That's, after all, what we're here for. We've already looked at the architecture of a Redis Enterprise node and how the proxy works. That's great, But as we move forward, there are several things we have to consider. First of all, we need to make the most of our compute resources. That's important if we're on-prem, but it's even more important if we're in the cloud. If we're paying for CPU and RAM that we're not using, we're wasting money. Secondly, we need to think about what we're going to do when we outgrow our current deployment. Our business, of course, is growing by leaps and bounds after all, so we're going to have to scale up or out as we go forward. And that scaling has to go smoothly. It can't interrupt our everyday operations. In reality, we'll need a dedicated ops team to handle the many moving parts in an open source Redis cluster. Redis Enterprise, on the other hand, was designed to use resources more effectively and simplify, and in many cases automate, the administration of multiple Redis databases. As an example, let's use the Redis Enterprise console to create a clustered, replicated database with 4 shards. We'll start by clicking the Add button to create a new database. It's a Redis database, and we'll make it geo-distributed so we can scale across regions. With those choices made, we'll give the database a name, make sure the replication box is checked, and click the plus sign to add more shards. Next, we need to add the database to a cluster. We'll type in the cluster's URL, add the admin's username and password, then click Activate to create the database. That's how easy it is to set up a database with multiple shards that's replicated across multiple Redis Enterprise nodes. As we talked about earlier, Redis Enterprise uses a proxy to give our applications a single endpoint. Things may move around, they may be resharded, they may be rebalanced, they may even fail and have other resources take their place, but our endpoint doesn't change. That makes building and deploying and managing our apps way easier. Redis Enterprise lets you scale out or scale up as your needs grow. Scaling out means adding more nodes, while scaling up means adding more shards to your existing nodes. Let's take a quick look at how those two approaches work. First of all, scaling out. We'll start with a single node that has 4 shards. And let's say that this node is reaching capacity. Resources are finite after all, and will reach a point where this node can't handle any more traffic. So let's add a second node. Now we've got twice the resources, so let's rebalance the shards across the 2 nodes. Finally, let's say that we want to use resharding to take our existing data and spread it across more shards. So without changing our endpoint or losing any data, we now have 2 nodes and 4 shards on each one, 8 shards in all. That's a lot more processing power and RAM behind the same amount of data, so we'll get much better throughput and much lower latency. The other approach is scaling up. In this case, we add more resources to our existing infrastructure. This is important because we want to make sure we're getting the most out of the resources we're paying for. If a node has lots of unused capacity, we can scale up instead of paying for another node. So let's start with a large database with a single shard. Let's split that single sharded database into 2 shards. So now we've got twice as many instances of open source Redis serving up our data, which means we should be able to double our throughput. When we move from 1 shard to 2, Redis Enterprise automatically reshards our data so that the data is spread more or less evenly across the 2 shards. But we don't have to stop at 2 shards. If our Redis Enterprise node can handle it, we can add even more shards. Now we've got 8 processes serving the same amount of data that we had before. Obviously, having 8 times as many shards gives us roughly 8 times the throughput. The final aspect of scalability we'll talk about is multi-tenancy. One of the great features of Redis Enterprise is its multi-tenant architecture. With open source Redis, you need another node for every database. With Redis Enterprise, you can host multiple databases and multiple replicas on the same Redis Enterprise node. Here's a look at 3 databases on 3 different nodes. Database 1 has 2 primary shards on node 1 and 2 replica shards on node 2. Database 2 is a single sharded database on node 1 and it doesn't have any replicas. And database 3 is a single sharded database with its primary shard on node 2 and its replica on node 3. The final point we'll make here is that we don't have any downtime whenever we use one of these scalability options. Our applications still use the same endpoint even as the underlying database architecture changes. We can add or delete shards on an existing node or add or delete nodes. It doesn't matter, our applications still work. Redis Enterprise scales to handle any size workload and any level of throughput, and it does it without downtime. Now that you've had a great overview of scaling, let's hear from a customer who used Redis Enterprise to scale. BioCatch provides behavioral biometrics to reduce fraud, increase customer trust, and increase profitability. BioCatch used Redis Enterprise to decouple compute resources and data easily and economically while scaling to manage significant data. Dekel Shavit, VP of Operations and Chief Information Security Officer, along with Alex Eichengeiler, a DevOps engineer at BioCatch, tell their story.
We use the way you interact with an application. Application could be a website or a mobile app to fight fraud and do other cool stuff like identity and authentication. So my team is responsible for the entire operation of the product for our customers.
Our service is provided to financial sector, so we had to maintain the service 100% uptime.
We want high performance database. The other thing is we wanted scalability, extreme scalability. So before we adopted Redis Enterprise, we had a problem, and the main problem was that the compute and data was coupled. It was hard to scale, it was expensive to scale. Redis enabled us to decouple compute and state, and actually, as of now, Redis is the only stateful part of our system. We looked at the open source Redis solution, we looked at the Memcache, and we looked at other solutions. The main reason we chose Redis Enterprise is because we wanted to have kind of Redis as a service solution. My operation department does not need to manage the entire infrastructure, and that's a great offload.
It keeps growing all the time, but for now I think it is just about 2 terabytes of data we store there, about 300 million of keys. We are using Redis in the US and Europe. I think we have about 40 databases in Redis.
We use Redis Enterprise running on top of Azure. We use Redis to serve data for all our components, our microservices. So it's a key component. We use it across the board.
Well, that covers our look at scaling Redis Enterprise. We started by looking at the architecture of a Redis Enterprise node. Then we talked about how the single-threaded proxy enables scalability. And we heard a real-world example from BioCatch that showed that scalability in action. We hope you've enjoyed this session and keep an eye on our website for more tech talks. Thanks.